Hello. Today we look into the fourth program of Unix Simple Stack. So the fourth program we have two basic conversion Unix script and we have six subtopics under it. So the first question is decimal to binary, binary to decimal, decimal to octa, hexa to decimal to hexadecimal, octa to hexadecimal, and hexadecimal to octal. So first we look into all these programs in an order. So this is a program for the first question, which is decimal to binary. So enter a number. So a number will be entered to be stored in num, and the binary value is echo I base equals to 10, O base equals to 2, and the number BC is a Hence calculator. So it's basically an inbuilt calculator in Unix programming. So instead of using a Windows calculator, Unix has in shell scripting. Unix has its own calculator, and that is a Bench calculator. So IBase is basically an input decimal calculator, and OBase is the output one. So I've given IBase equals to 10 and OBase equals to 2. So let's see how this program will be run. So enter any decimal number. I'll give 2.1. So binary value is 10.0001. So the value will be printed automatically. So the first program has been compiled and run successfully. So now we'll look at the second one also as well. So the second one is so this is the code for the second program. Second question in fourth program, that is binary to decimal. So we have done it in a different way. Instead of using the IBase value, we have used a logic to convert it, and then it will be displayed on the output screen. So first we'll enter a binary number, and it will be stored in bino, and the length of the bino will be stored in len. And I've given a variable. I've taken some variable called I is equals to L, and this is the code for that. And here what happens is that uh, here I have given power is equals to ampersand length, and that is 1. And while I have given is ampersand I is less than length, then the following code will be executed. Here echo Pino, so the value of Pino will be displayed over here, and printf the value of I will be displayed over here. And I have taken two more variables, j equals to 1, p equals to 1. While j is less than or equals to power, what happens is that do ampersand p into 2 and j plus 1. So these two conditions will be executed. Once that is done, the decimal value will be stored in DAC, and find DAC will be stored in find DAC, and power will be stored in POW, and I equals to ampersand I plus 1. And once that is done, the final decimal value will be displayed on output screen. Let's see the program. So we'll enter a binary number. So the binary number is 10111, and the equivalent decimal number value is 23. So the 4P has been run successfully. So this is the C program for that, and this is conversion from decimal to octal. So here we take the number value and it's stored in NUM, and I've taken something called reminder REM equals to 1, and here I've taken B number equals to nothing, binary number equals to nothing, and I've just left it as a free space. So I've given some condition called while num is greater than 0, do REM is equals to EXPR ampersand num percentage 8. So it will be modulus will be done over here, and that will be, and for BN also BNO, it will be stored in BNO, and number also we do the same thing, but instead of modulus we divide the value now. So once that is done, the value of BNO will be stored in I. So the final value will be is equals to final equals to in semicolon select is a free space, while I ampersand I is greater than 0. If it is greater than 0, what happens, reverse of the string will happen, and final value will be stored in final. So let's see the program. Enter any decimal number 23. So the equivalent octal number is 27. So the program has been run successfully. Now let's look at the fourth program. So here we use something called IBase, and here IBase. So basically IBase is something 10 is decimal, because the question given was decimal to hexadecimal. So basically decimal base is 10 and hexadecimal base is 16. So instead of so while taking the input, the base will be taken as 10, and while giving the output, the value will be converted to 16. So let's look at the program now. Let's look at the output now. And the value to be converted, I'll give 24. So it will be converted into hexadecimal, and it has been run successfully. So let's look into the So here also same thing where we use IBase. So here we have to convert from octal to hexadecimal. Here we have to convert from octal to hexadecimal. So here the value has been already given. So IBase equals 16 and OBase equals to 8. Let's see the program now. Enter a hexadecimal value. I'll give some 16. So the converted hexadecimal to octal is 26. The value has been converted properly. Let's look at the fourth program. So here basically the value has to be converted from hexadecimal to octal. So here also we give the same thing, and the base is O base is equals to 8 and I base equals to 16. So hexadecimal talking basically the input should be hexadecimal and the output should be octal. So let's see the program now. Let's see the output now. So so there was a small error in the code. Changed it. So see the program now. So enter the hexadecimal number that to be converted to octal. So I'll give some 34. So the value got converted to 64. So all the programs have been run and compiled successfully. Thank you.